And I'm live. That is pretty cool. And today is 22nd of January 2026, Thursday. And with that, let's just start solving some questions, some problems, not questions, in code forces at a rating of 1500. We go to problem set and difficulty would be 1500. And yep, let's solve some problems. Min, max, mex. Let's start with this one. Okay, and yeah, let's solve some problems. Competitive programming, start, new update, synchronize, and okay, and yes, also stopwatch, not stolen, stopwatch. Okay, that is cool after a very long time. Okay, you are given an array A of length n and k numbers. A subarray is defined as a sequence of one or more array A of length n and a number k. A subarray is defined as a sequence of one or more consecutive elements in the array. You need to split the array A into k non-overlapping subarrays b1, b2 till bk such that the union of these subarrays equals the entire array union. So non-overlapping. Okay. Additionally, you need to maximize the value of x, which is equal to the minimum mix of any bi. Minimum of mix. Okay, mix v denotes the smallest non-negative integer that is not present in the array v. Okay, we have to minimize this minimum mix. Okay, and there are going to be k arrays. Okay, if there is a 0, and also these, okay, and also the subarray, a single subarray is of consecutive elements. Okay, and each of these arrays b1, b2 till bk, they are non-empty. They must have something. Okay, minimum of mix. The length of the array and the number of segments to split into the array n and k, and then the array itself. N and k. Here the answer would be 1. Yep. And here k is 1. So answer would be 5. Answer is 5. Here 2. 2. Share answer would be 3. Yes. Answer here would be 3 because we would like. Yeah, answer would be 3. Answer would be 3. Wait, answer could be 0 if we take all of these into one array and this into one array. And since we are looking for the minimum mix, the mix of this one would be 0 and the mix of this would be 3. Therefore, minimum is 0. So answer should be 0, not 3. So why is the answer 3 in this case? You need to maximize. Okay, shit, we need to maximize. Okay, makes sense. We need to maximize. Maximize. Can we always, okay, 5 in this answer would be 1. Answer is 1. Here there is no 0, so answer would be 0. Yes. Yep. And in this case, 0 is there. We would like to give all of these arrays that we make a 0, a 1, yeah, all of the numbers is starting from 0 till the highest number. But in this case, if we were to split at this point and give one zero to one array and another zero to the second one, then this first array won't have any one or twos. Therefore, the max of this one would be 1 and the max of this would be 3 and the minimum would be 1. So answer is 1 here. And here we have 4 and yep, answer here would be 0 because the max of this one is 0. Okay, let's write some code and boilerplate n and a shit. Okay, okay, I have to fix a little thing. Hello, hello, how is everything? Bro, you no, I didn't complete CP31 sheet because in CP31, if you go to CP31 and try solving higher rated questions there, like 1600 or 1500 rating, they are as difficult as the latest 12 or 1300 rated questions problems. So it is much better to solve mm, more current problems than those like old problems. Yep, back. I also completed CACS. Wait, you completed CACS sheet, CP handbook, but you suggested me CP31 sheet or any other resources which is good apart from doing contests. Yeah, CP31 CP handbook has, I think, all of the resources or topics at least that you would require. So, yep, that should be enough. And focus more on just learning new things instead of finding the best resources. These three things are enough, like good enough. And I am like not at a higher rating to suggest anyone something. Yeah, these are the things that I follow. And also there is introduction to Bessel functions. No, introduction to algorithms. This book, if you want to get like comprehensive understanding of some specific topic, you can read a chapter from this book. For dynamic programming, I used this book, and here, dynamic programming, greedy algorithms. This book is pretty cool for specific topics for comprehensive knowledge. Shit. Okay, I guess you don't need my recommendation. Should 1537? Wait, yes. I have to change settings. Yep. Here, shortcuts modifier keys so that the caps lock acts as the control key, which is very useful when you are using Vim. Shit, but not the caps lock of your laptop's keyboard, but the caps lock for your external keyboard. Keyboard shortcuts, modifier keys, USB keyboard, control. Yep, there you go. And N, N, and K, and vector int A, size N, for int reference X and A, taken X, and now, okay. What should we do here? If K and this, okay. So we can at least put a higher limit, upper limit to the solution, not ChatGPT, Excalibur. We can put a upper limit to the solution. For example, if we have some n numbers in the array and we need to divide them into k lists. If we were to give each list the same size, some extra, then n by k lower limit would be the maximum number of elements that can be in a single list if we were to divide all the elements equally. And if, let's say, this number is x, then if then the maximum mix that we can get out of x digits is going to be x, because when we have x digits, they will start from 0, 1 and go up till x minus 1, in which the mix mex would be x. So the maximum answer would be x. Okay, and the minimum would be 0. We are looking for maximum. Can we apply a binary search here? Can we apply a binary search here? What would the binary search look at? If, okay, let's see. Let's say for this, here this is 2 and 6 by 2 is 3. So we are saying that the maximum max can be 3 and the minimum would be 0. The best case answer would be 3, and okay. So our range is from 0 to 3 for our answer. And if we were to say, let's check for 1, is 1 possible? Okay. For our mix to be 1, what would we need? Okay, do we want exact 1 or at least 1? If we want at least 1, then we have to check if we want at least 1, or whatever the current m number is, m max is, that we are checking for. We need to make sure that every division that we are making is of size m at least, and all the numbers from 0 to m minus 1 are there. And there are other requirements also, that all the numbers from 0 to m minus 1 should appear in the array A at least k times, right? But then we also have to look at the order, because the divisions have to be continuous. In this case, we have all the numbers from 0 till m minus 1. M is 2 or even 3. For 3, m equals 3. We have all the numbers 0, 1 and 2, and they do appear k number of times. K is 2 in this case. So we have 2 zeros, 2 ones and 2 twos, but the order is not correct. And the required wait, shit, yes, we can do this. We can do this. We can do this, yep, by using a greedy algorithm. Here, when we are checking for a specific m, if a specific m is the answer or not, we can just start with the first element, and we will keep a counter. We will keep moving forward till we get m as the max. Like if we were to start on this first element and our m max is 3, we are checking if we can make 3 as the max of every division that we make. If we start here, then our current max cm, let's say, would be 1. If we are starting from here, then we go right till one element, it is still 1. Then we go right with one element, and max now of these 3 elements becomes 2, and going right by one more element doesn't change that. But when we go here, max becomes 3, and we call this thing one partition. And yep, we will say we have made one division, right? And then we will start a new list starting from this next element, and the mix would be 0 here. Yep, the mix would be 0 here, and yeah, we won't be able to make mix equal to 3 in this case, and also we won't be able to make enough partitions, so therefore 3 is not possible. But also, if we are doing this, we will not always get the numbers in this order, in this nice order that we had them here. Like if our list is like this, 4 2 1 0 and 0 1 2 3, and if we start from here looking for a mix of 4, which is possible when k equals 2, the actual divisions would be this and this. But let's say we start from here and hello. Give lead code contests as well. You will perform well in them, and you need a title to show in your CV. And I think you will be able to reach lead code knight easily. Shit, I guess knight is a position there. Okay, I will see. Like, but um, I can say that I am a pupil in code forces. That is also some like a rank to show. But yeah, I do not like going to different platforms. Mm, I think code forces is enough for just improving and stuff. And yes, here if we start from this element, the current mix, how do we find the current mix? Mix whenever we add a new element, because when we move till if when we have moved 3 elements, our current max cm would be 0, and then we see 0. Yep, then we see 0 and our max would become 1, but we already have a 1. Our max would become 2, but we already have a 2. Our max would become 3, but we already have a 3. So whenever we add a new element, we have to go through the whole list, which is not very good. And the time complexity would be n square in this case, just for checking if a single number is a mix or not. So what we are looking for is a way, if we know the mix of an array, is there a way to know the mix if we add one more element to the array? If the array was in ascending order, that would have been very cool, but it is not. And n square, can we do n square? No, we cannot do n square. Nope. So we have to look for something resembling O of n for finding out whether a certain number can be mix or not, if we are using binary search for our algorithm. But if we are not using binary search, then no. Let's say we are using binary search. Binary search seems cool. We can, without a doubt, make a list of the minimum, which is always 0, and the maximum mix that we can hope for. And yes, and for each value, we will call a function with the array A and some current max value that we are checking for. And this whole binary search process would take log n time, log m time, log m time, and this function can at max take x time. So log m into n, which is like n log n, which is good, but this function cannot take n square time, which is what is happening here. Okay, if we were to reduce the problem down, it would be 3, 2, 1, 0, and we are moving right one by one, one element by one element, and we want to find out the max after every single step. Okay, and after moving every single step, we will account for the mm, new number that we have taken into our array, but we also have to look at all of the numbers that have been in our array. Yep, yep, and yep, 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 we have to do that. Yep. And we might also have some complicated pattern like 3, 4, 6, 2, 1, 5, 0. In this case, the max would be 7 when we are at the last element. But how do we know that? When we are only considering this much of the array, the max would be 0. But when we consider this last element 2, the max would jump up from 0 to 7. And for this, we do have to go through all of the elements that we have seen. Or maybe we can break up these numbers into segments, continuous segments like 3, 4 is one continuous segment. We can maybe keep track of the starting and ending point of segments, and also the max would just be ending point plus 1, so starting and ending point. And when we are, and let's say when we start from here, we will have the current max, and the starting and ending point in this case when we only have a single element would be 3, 3. Then and current max would be 0 when we only have 3. Then we move on to the next element and we see 4, and we will see, yes, we see 4, and we will see, is 4 extending a starting element or a ending element in one of the pairs? Yes, it is. Here it is extending, so our range would change from 3, 3 to 3, 4, and the max would be 5 when we only are considering this much, and we are supposing that we have 0, 1, and 2. So 5 and current max would still be 0. Then we move on to 6, and 6 is not extending anything, so we will make another range, and then we move on to 2, and 2 is extending this one at the starting point, so 2 till 4, and here still 6 to 6. And this lookup process, whenever we have a new element like here and we are comparing that with all of the pairs. At max you can have n pairs, and if we store these pairs in a ascending order, which is easy to do because mm, these are continuous ranges, that would take up log n time the lookup, and we will do each lookup for every element that we go through, that is n time, and this n log n is the time complexity for this for a function which takes in the whole array A and a number m, which we are checking if it is a mix or not. And we will be doing this whole process log n time. So if you were to look at the total time complexity, if we were to move forward with this method, the total time complexity would be n log n log n, and log n into log n is log n square, which is 2 log n. So 2n log n, which is just n log n in big O notation. I hope I have not messed up this part. Log n into log n, 2 into log n equals log n power 2, I think. Yes, this thing I think is okay. Is this square on 2 or on log? Okay, shit, this square has to be on 2, not on log. Shit, okay, so yep. No, the time complexity is not n log n, it is n big O of n log square of n, which I think is not too bad if we do manage to do this problem like this. Okay, and when we move on to 1, we see that 1 is extending this one. So 1, 2, 4, and 6 to 6 are new ranges. And then we see 5, and the current max is still 0, and 5 is extending this one, this list towards the left, and yes, we do have to do 2 searches, one in the starting points and one in the ending points, for which we can keep 2 vectors. One vector would keep track of all the starting points, which would look like 1 and 6, and another would keep track of the ending points, which are just 6, 6. And then we see 5. 5 is, we'll see if 5 is extending a starting point, and yes, 5 is like just 6 minus 1, 5. So we will say 1 comma 5, 1 comma 5, and here we want 5 to extend something towards right. So yeah, we see 4, so that becomes 5 and 6, and we see that these two numbers are equal to each other. There is a match in both of these, so we can just remove them, which is again not very good. Yep. 1 to 6 would be, yeah, shit, we would get 1 to 6, and removing we are removing some numbers, which is not very good. Removing numbers is not good in an array, and also there is the overhead of creating these arrays. The max here would be 7, and then we see 0. 0 is extending this. 0 is extending this, and we see 0, and 6, where the max is 7. So good enough. Okay, removing elements from an array is not a very good thing because we want the array to be in ascending order for fast lookup. Yep, we want the array to be in ascending order for fast lookup. But we can also use the fact that we want all the numbers in ascending order. We want all the numbers like that. We know the target m that we are looking for, so we are not just looking for a random mix. We know the mix that we want, and for a subarray to have a mix m, we need to have all the numbers from 0 to m minus 1 in that subarray. Okay, okay, which we can do, which we can do if we have a heap. Shit, yes, we can use a single heap. We can use a single heap, and whenever we see a number which is smaller than m, we will add that number to our heap or to our set, and we will keep doing this till the size of our set becomes m. At that point, we know that the max is m. And since we are only adding numbers which are smaller than m, so yeah, we will have numbers from 1 to m minus 1 once. And for the next subset, we will keep removing numbers from this till the size becomes 0, and then we will know that the current max is m. Okay. Okay, I think we can do that. Okay. Int min and max, or int r comma l equals 0. R would be equal to n divided by k, which is the maximum answer, and we will have a function which returns boolean is okay or just okay, which takes in a vector integer reference a and an int m, which we are checking if it is max or not. Bool okay equals true, and here return okay, and here, and the range for our answer is L is possible and R is also possible. So let's change it to this. And how do we find the upper limit? If k divides something completely, then also the lower limit is okay. Plus 1, plus 1, for which we can just here say n plus k, but this is also okay. So now our range is L to k. So while we have r minus L greater than 1, that is when while we have more elements in the array, more than one elements in the array, we will keep doing this. Right? And at the end, our answer would be L, C out, L, okay, and int m equals L plus or L, yes, L plus r minus L divided by 2. And if okay, a m, if this is okay, then L equals m, and otherwise, if this is not okay, then r equals m, because r is never the correct answer. Now we just have to implement this function, this okay function. Yep, long time no see. Now you can see. And yeah, cool. Okay, and yes, this is the question that we are doing right now. Okay, this function is the only thing remaining. And shit, what is the algorithm that we devised? Yes, set. We will use a set. So a set of integers. Let's call it max. Okay, and we need a couple of things. One is we already know the max that we want to check for, which is m. And yes, also some comments. Uh, checks share. We also need to know k. Makes sense. We need k here too. Checks if a can be divided into k parts and k parts and have m as the max. Okay. Int cm current max. No. Parts equals 0 initially. How many parts? Okay, we can move for int I equals 0, I is smaller than a dot size, or we can just here say int n equals a dot size. N and I plus plus. Okay, okay. If and also a boolean number bool. Okay, naming a variable is more difficult than defining what it should do. Bool even false. Okay. If the current number, which is ai smaller than m, then if even, let's make even true at the start. If even, then we will add to max dot insert ai, else max dot erase ai. Okay, and after making a change, after making a change like this, insertion or deletion. Yes, we can do this right here. After inserting, if max dot size equals m, then we know that we have made a successful division, and we will say even equals not even, and parts equal parts plus plus. And in this case, if max dot size equals or max dot empty, if max is empty, then even equals not even, and parts plus plus. Okay, parts plus plus, and yes, that is actually good enough. And at the end, so we don't need this okay or stuff like that. At the end, we can just say return parts must be greater than or equal to k. Parts must be greater than or equal to k, and I think we are good to go. Let's see, and shit, okay, it is actually working. That is pretty dope. First try. Okay, no, we cannot stop the timer just yet. Okay, C++ 20, 17. Okay, Oh shit, that is like actually unexpected behavior. This is working. This is working. Cool. It is taking quite a bit of time, but yeah, that is cool. We took 38 minutes, which I think is not very good, but fine. I really appreciate your consistency over the year, a full year of YouTube coding live. All the best. I wish you to see you in the future. Yo. Okay, yes. Thank you. Good. Oh Lord. God. Oh Lord. But as Nietzsche said, God is dead. Yeah, and yes, I'm like actually trying to be back and planning some other things other than live videos. And hello, how is everything going on? Kakashi, Hatake. This is good. Memory is very bad. 42,420, 4200 tutorial. Okay. E. This was actually E, min-max for division 3. That is good. How to check if a solution exists for a fixed x. Literally what we did. We can use, okay, so, okay, our solution was not too stupid. We did use binary search, so that is good. To solve the problem, we use binary search on the answer. To do this, we need, okay, their time complexity. Okay, let's calculate the time complexity of our solution. This whole part takes n log n time, and each call to this function, to this OK function here, each call takes n time, like goes through each element, and for going through each element, this is inserting and removing, which we can say is log n time. Yeah, this is the time complexity would be big O of n log n, where we have log n multiplied by log n. Yep. Hello. That's why CP is pretty cool. And the evolution website is like minimum viable done. And yeah, we can add more features later on at some point. Okay, let's read the pro solution. To do this, we need to learn how to check for a given x whether there exists a partition that allows achieving an answer of at least x. Yes, exactly what we did. To do this, we will collect the segments one by one. That is, first we will find the minimum valid first segment, then second, and so on. Since the segments must be non-overlapping and must give the entire array in union, it means that in a correct partition, there must exist a segment containing the first element. Also, the max of this segment must be at least x, which means it needs to be increased until the max becomes greater than or equal to x. Yes, which is true. As soon as this happens, it makes no sense to further increase the segment, so we can move on to choosing the next segment, move on to the next element, and begin the selection of the next segment. True. To maintain max on a segment, yes, this was the tricky thing to figure out. To maintain max on a segment, we can use a counting array and a variable in which we store the current max. When a new number is added to the segment, we run a while loop, and while there is a number in the segment equal to the current max, we run a while loop, and while there is a number equal to the current in the segment equal to the current max, we increase max by 1. This works amortized in, okay, shit. I thought this will give n square time complexity, but they are saying this works amortized in the number of elements in the segment, since max on the segment cannot be greater than the length of the segment. Yes, yes. So I thought this would be like too much. This would take up too much time. But let's see. Check. This takes in n and k. Okay. current max equals 0. They start going through the elements if the current element is smaller than v dot size, where v is the okay. And how are they deciding what the minimum and maximum answers should be? Equals 0 vector v taken, okay, l and okay, that is also something they can do, yes. While okay, is l is always answer and r is never the correct answer. So while the range is greater than 1, m equals r plus l by 2. Check if this is true. Okay, cool. Okay, our range is more correct, uses more things, but yeah, this will also work because uh, r reduces by logarithmic rate, so yeah, does not really matter. Count equals 0. Current mix and count. If the current element is smaller than or equal to v dot size plus 1, v dot size plus 1, that it is, and that is it is a possible candidate, then nums v equals 1, where nums is a vector array where every value is equal to 0, and okay, while nums current mix is there. Okay, should, yes, that is true, that is correct, makes sense. Okay, yes, this will work, this will work. Yes, shit, yes, this will work, this will work, this will work. This will not take up too much time. At max, this will go, this part will go through. Wait, but they also have to empty this nums. Current mix greater than equal to m. Current mix greater than equal to m, then count plus plus, and for j equals 0 till minimum of m plus 1 or int v size plus 2j plus plus nums j equals 0. Yes, that is what is meant by making it 0. And current mix equals 0, and we go through, yeah, we look for the next segment, and at the end count should be greater than equal to k. Okay, their internal function is a bit different than ours, but yeah, essentially they are checking for the same thing. All the best, thank you, and to you too. Let's like get better together. Okay, let's apply their solution. This is also good, this is also good. Okay, this is what we have done. We are using sets and stuff, and we will also compare how our solution runs compared to theirs. We won't use sets or anything. We need a current max equals 0, and the thing is, this vector, they are initializing outwards, and they are using the same vector for all of the test cases, which I think is better than initializing one vector for each call of this check function, because because initializing a vector again and again is not a very efficient thing compared to using a single vector and rewriting its values by 0. So yeah, let's use the same thing that they did. Vector of int. We will not use the same name because like ego issues. We will use a different name. We'll say, we'll call it present, and this will have at maximum what can be the value of n, 2 into 10 power 5. That is not too much. Let's say 10, wait, 1e6, and every value is 0, which we don't have to specify. It will be 0 by default. Okay, and int count or parts equal 0. And at the end, return parts must be greater than equal to k. We want to have k parts. Okay, for int I equals 0, I smaller than n, I plus plus, but n does not exist. Yep, n equals, if you can just say here, n equals a dot size. Okay, and if a I is smaller than equal to n. If a I is m, or we can even remove this equal to, yes, m, then we will say present a I plus plus. Okay, present a I plus plus. We are saying that we have seen ai at least once. Okay, and then a while present current max. Yes, while current max is present in our array cm plus plus. Cm plus plus. Now, if current max is greater than equal to m, the max that we are looking for, then parts plus plus and parts plus plus for int reference x, no, for int j equals 0, j is smaller than equal to m, j plus plus, we will say j plus plus, we will say present j equals 0. And yeah, I think this should work. This should work. This should work. And also cm equals 0. Uh, Run and correct answer. Let's compare the times. Okay, we messed up somewhere. Parts equals 0, present E1, E6, parts, current mix. We are going through all of the elements. If ai is smaller than m, if the current element has some contribution in the mix, then we increase its count by 1 in the present vector, which is this. And while we have the current mix present, we increase the current mix. Yes, and if the current mix is greater than equal to m, we have made one part successfully. This should be correct. This should be correct. What is the problem? For j equals 0, j is smaller than equal to m, j is smaller than equal to m. Yes, j is smaller than equal to m, because any number that whose value is higher than m has no contribution currently, so we can do this. But shit, we cannot do this. Yes, we cannot do this. We have to make n. Okay, shit. Okay, that is a bit sad. And here also, here, not this, not this. Here does not matter if we use m or n, but here we do have to update all the n values. Yes, we have to initialize the whole present vector to 0. Present vector to 0. Yes, correct. And yep, this seems good enough. This should work. This should work at least here. Yes, it does work. Let's check if it works here. Hello, what are you doing in the corner? Shit, there is something in the corner. Easiest 1400 rated problem. I got contest. This. Okay, I dare you to solve it in. Okay, okay. We are getting competition. Mm, okay, we will solve that one like just after this one. Test. Okay, I do not want to look at which solution was wrong or like what is the specific test case where we got this wrong. We should be able to predict which test case, like for which test case this fails. Hmm. Present 0 equals 0. Yes, I think if we move this from here, because now I'm thinking that there are leftover values in present, in the present vector after one test case finishes. And an example where this would fail would be, let's say we have two test cases and one of them has a larger value. Um, no, this should work. This should work. No, I think we should clean everything after not this point, but this point too, just in case. Let's see if this works. Okay, no, that was not the problem. There seems to be no problem here. Let's look at their code. Yes, they have a few changes like they are only updating nums when vi is smaller than or equal to v size plus 1, but we have m here. M is the current max with for which we are checking, but this also works. Max works on this also works. Yeah, both of them are correct. Nums current max, yes. And if greater than equal to, yes, current max is greater than equal to m the target max, then count which for which we have parts, we increase that by 1, current max becomes equal to 0. And no, no. Okay, they are initializing, putting everything equal to 0 after this point 2. Let's do that. For int I equals 0, or yes, for int I equals 0, I is smaller than equal to n I plus plus. Wait, k is not bigger. Yes, k is not bigger than n. So yes. Um, Present I equals 0. After each call, we update this. And here, instead of going to the whole n, we can say minimum of n or m. Yeah, that works here, should also work here, probably. Okay, okay. The cleaning up, this part was the problem, cleaning up. And yes, this is actually faster than what we did because we were using sets and stuff, which is not very cool. And if we were to change this, I think the time would increase. The time in which this time would increase if you were to change this. Let's see. Yeah, it seems like it is taking longer. Yeah, it is definitely taking longer because at this point the time complexity is like n square for each of this okay function call, and we are calling this function log n times, so the time total time complexity is time limit exceeded. Yeah, so we have to go for the minimum of n or m, which does work. And now we can move on to the deer. I have to solve it in 10 minutes. Okay. Which webcam software do you use? It is pretty cool. Webcam, since I somehow have a MacBook and an iPhone, so I can connect the MacBook and iPhone camera, which is pretty cool. And yeah, my phone's camera acts as the webcam, but I think you can even do this with Android phones. My friend was doing this yesterday and showing me things in his room. Yeah, you can connect your laptop with your phone's camera and use that as the webcam. And for streaming, I'm using OBS. And let's solve this question. Shit. Contest 181. Okay, that is not how you enter a URL. Contests. If you go to a random contest, contest number is 1883. 1883. Okay, and here we have to solve question number G1, which is already solved. I solved that at some point, but okay, let's check the memory. I will solve it again after some water. This one, easy dance. Okay, it was first try. Okay, this is the easy version of the problem, and the only difference is that this version has m equals to 1. You are given two arrays of integers a1 to an and b1 to bn, okay, same size. Before applying any operation, you can reorder the elements of each array as you wish. Then in one operation, you will perform both of the following actions. If the arrays are non-empty, we can rearrange before operations, okay? And in one operation, we choose any element from array A and move it. All the remaining elements are shifted to a new array A. Choose any element from array B and remove it. All the new elements are shifted to a new array B. Let K be the final size of both the arrays. You need to find the minimum number of operations required to satisfy that each element in A1 is smaller than B1 for all I, and K should be the final size. Okay, this problem was too easy, so the problem author decided to make it more challenging. You are given a positive integer m. Now you need to find the sum of numbers to the problems. Now you need to find the sum of answers to the problem for m pairs of arrays. M pairs of arrays C1 to B, where this. Okay, I is between 1 to m. Array C1. Okay, shit. M is always 1 in this case. M is always 1, so we don't have to focus on this part. The minimum number of operations required. The final size is, since it wouldn't the answer always be n minus k, because the final size is k, and yes, because the final size is k, must be k. Huh. Okay, sizes of A and B are different. The elements of each array as you wish, then in one operation you will perform both of the following actions. If the arrays are non-empty, we have to remove one element from A and from B. Okay, and in each line we have n and m. M is 1 in each of these cases, and okay. Okay, the maximum size of k. Okay. Why is this second array always like one element bigger than the second one? So A and B, the size of arrays A and B, and the constraints on the value of the element A1. Okay, we have to beat this part also. This problem was too easy, so the author decided to make it more challenging. You are also given a positive integer m. Now you need to find the sum of answers to the problem for m pairs of arrays, where I is m 1 to m. Array Ci is obtained from A as follows. Array Ci is obtained from A as follows. Ci is an array. The first element in Ci is equal to I, and the jth element is equal to Aj. Okay, the first element is changing. Okay, and since m is always 1, so the first element is always 1 here. Okay, and finally we want all the elements in A strictly smaller than all the elements in B. Strictly smaller. Therefore, we need to, what is the smallest element in B that we can choose, which is bigger than one element in A. But we can just arrange A and B in ascending order. Arrange A and B in ascending order and look at the smallest element in B. Then we will have two pointers, one in B and one in A. In B, okay, from B, our goal is to choose as small numbers as we can, and from A, our goal is to choose as large numbers as we can. So we will begin one pointer from here and another from here. Nope. We will use some division of elements from B. In this case, we can use, yes, so B here is already sorted. So we can never use ones. So yes, that is one thing. And we can use 3 for this, with this, with this, with these 4 elements. So answer would be 4 in this case, because we can remove these 4 numbers. Answer is 4 here. And here we have 1 1, 2 2, 3, 4, 5 5, 6, we want to choose the smallest. Smallest is 1, which we cannot, mm, which does not go with any elements. We have two twos, which can go with 1 from this array, which is the first element, which is like not here right now, but will be. Okay, let's write some code. Int n and m, c in n, and m, and vector int a size n and b size n, and then we have a 0 is always 1, and then for int I equals 0, I is smaller than int I equals 1, I is smaller than n, I plus plus c in ai, and here for int reference x n b c in x, and sort a dot begin and a dot end. uh, do the same with b. Okay, sort both of these, and from b we want to choose as small numbers as we can. Okay, and rest equals 0, for int I equals 0, I is smaller than n, I plus plus auto lower auto ip equals lower bound in a dot begin till a dot end for b I, begin and end in b I, and if it, if, or not if, but I, or res equals maximum of res, or a dot end minimum a dot end minus it, comma a dot end minus it, or the remaining number of elements to the right in b, including the current element I, that would be n minus I minus 1. A dot n minus it, what is the no matching function called? To min, how? A dot n minus it, that is a single number, n, yeah, now it works. And again, see out res, and hopefully this works, or it might not. Okay, 2 7 8 7 and 8 are not even close to the correct answer. So I forgot you already have solved CP31. It is a CP31 problem. I completely shared. Anyways, it has been 11 minutes, and it seems like I have failed to solve it in 10, but it is fine. It lower bound a dot begin, a dot end. This seems correct. Maximum of rest or minimum of this, and this is 2 for the second test case, which is this. Is this. This is the second test case here. This is A and the second one is B. 8 and 1 1 5 5. Okay. So when we are moving element by element, when we are moving element by element in B, we are here and we look at the smallest element in A, which is this. And the hypothesis is wrong. Shit. Okay, yes. Shit. It is wrong. Yeah. If I, okay, I assumed that if we can choose this number with this number, then we would be able to select at the end, use this whole array with this whole array, because we can certainly choose 3 and 3 with 1 and 1, but we cannot choose this 3 with this 5 because that is bigger. And yeah, the correct answer for this should be 1. Should be 1. Yep. So yeah, my initial assumption was wrong. And even if the assumption was correct, res is the maximum number, the maximum answer. Yep. And therefore the correct answer would be, yeah, res is the maximum number of elements we will get at the end, which satisfy the condition where bi is smaller than ai, bi is greater than ai. So yeah, this is wrong. Res n minus res would be correct if that assumption was correct, but the assumption is wrong. So yeah, this would not work. Hmm. Hmm. Wait, we can just shit multiset of integers a and b, a dot insert 1, and yes, for int I equals equals 1, I is smaller than n, I plus plus, and c in c, and a dot insert c, and for int I equals 0, I is smaller than n, I plus plus, c in c, and b dot insert c, and here int mx, maximum number of elements we can have at the end is 0. Then we will move element by element in B to for auto IT in B. For auto IT in B, auto iterator in A equals lower bound A dot begin and A dot and look for go to this. Like, oh, why is this error requires dot. This is iterator, so we have to go to the iterator's position like this, right? Okay. So what is the type of this thing? It is variable type passed by constant reference auto passed by constant reference. It says the same thing. Okay. If it a not equal to a dot, and in that case we can use this element, so mx plus plus and a dot erase iterator from a and see out the answer, which would be n minus mx. Hopefully this is correct. It is not. Shit. Okay, that is very bad. 18 minutes. Not very good. Wait. For legendary grandmaster. Okay. Some communication. Mm, 2 is not even close. Mx equals 0. The maximum number of elements which we can have at the end if we have a number in A which can go with this current number in B. Yes, then cool. Wait, lower bound. Shit, yes. We are not looking for lower bound. We are looking for upper bound. My bad. Upper bound, that is the smallest number that is greater than IT. Now it should work or not. A dot upper bounds IT auto ITA equals to zero. Yep. Why is this returning one or two when we are looking for upper bound? Shit. Okay, makes sense. If this is the first element, is not equal to a dot begin, and here look for lower bound. Okay, lower bound will give us the smallest number in A, the smallest number in A, which is either equal to IT or greater than IT. Okay, and which is not we are looking for, which is looking, yes, which is not what we are looking for. Upper bound IT, yes, A dot upper bound IT, find a number that is smaller than this current number. The smallest number that is smaller than this current number, IT. Right, right, and A is in ascending order. Yes, and IT. If this is not the first number, then there is a number which is smaller than IT, which is good, and we will erase that number, remove that number. One, 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 two, two. This is what happens when you stop solving problems for a while, but yeah. Yeah, one more one here. One, okay, lower bound. What does lower bound return? Lower bound and upper bound. Yes, that's just in case. And C++. Lower bound and upper bound are standard template library functions used in binary search. Lower bound returns an iterator pointing to the first element in the sorted range that is not less than the first number that is not less than uh, greater than or equal to a specific value, a specified value. Shit, okay, I like confused them. And upper bound returns an iterator pointing to the first element in the sorted range that is strictly greater than a specified number. So if we use lower bound, that will give us the first element in the sorted list that is not less than the greater number. Lower bound will give us a iterator pointing to a number that is not greater, either equal to this IT A iterator is now pointing to a number that is either equal to or smaller than IT, equal to or smaller than IT. Okay, we don't want equal to, we want smaller. No, we don't want equal to, we want smaller. Therefore, we can say IT minus 1 here. So, yep, if we get a iterator, that is the number that we can use. So that is cool. We are getting a number that is either that is always smaller than IT, and if yeah, not equal to end, yep, then we can always choose this. Okay, that might just work or not work. Shit. This is 0, 1. I'm messing up hard in this. Shit. And the address of the problem. You can look at it here also. We spent 38 minutes on that other 1500 rated problem. and 26 on this. A dot lower bound IT minus 1. From B we are going from smaller to bigger, and for this smaller element in B we are looking for the biggest element in A that we can choose. For that we want our element, the biggest element that is smaller than IT minus 1. Okay, and if there is such an element, then we increase our mx and do this. Okay, this is correct. This should work. This should work. A has 1, 2. A has 1 and 2, and B has 2 and 3. Okay, and when we are at 2 from A, we will get a pointer to this thing, which is not the end. So yes, we will increase our mx by 1. Mx would be 0 plus 1, right? Then we'll move on to the next element and we will get a pointer to 2. We will increase our mx by 1. So mx would become equal to 2, and then we are returning n minus mx. Mx is 2 and n is also 2. So 2 minus 2, we should be returning 0, but we are not returning 0. See out. Mx is 1, which is not correct. 1, 1. Mx became 1 in this first go, but yeah, okay. Print IT space. This should be 2 and then 3 and then 3. Why didn't this work? See out, go to IT A with a little space. 1 and 1. A dot erase IT A. A dot insert 1. Yes. And okay, that is all correct. Insert C. I also print IT with a new line. 1, 2, and why are we getting 1 always? That does not make sense. Why are we always getting 1 always? For this 3, we should be getting 2. 1, 2, which is correct. Go to ITA space IT. This should be working. Why are we not getting a pointer to 2? We are getting a pointer to 1 instead. Because shit, yes, both of them are 1. So what is the problem? See out IT A equals A dot end. put this. These, okay, 0, but second one was true. Why? A dot and C dot A dot size. Size was 2 and then size was 1. Okay, go to what is the first element? 1, 1. That is this erase not working? A dot erase it a erase that thing. In B, when we have a number which can work, link, share link, here's link. Use two pointers. I solved it using two pointers. Mm. Yeah, it was basic. I thought, how is it 1400 rated? I am messing up. Share links are not shown. Wait, are you sending some links? Okay, I guess you are not able to send a link. Let me show you a 1300 rated problem and we'll say it is less than 800. 8. A and B, you are saying we can use two pointers. But now that you have said use two pointers, I do not want to use two pointers because that feels a little bit like cheating. But okay, if there is no other way, then we'll use two pointers. And I guess two pointers in the sense that we will look at the smallest element in for every element in B. Let's say there is some element in A with the greatest element in A which can go with that element in B, right? So if that is true, then all these elements will work with this, and if we are choosing this element to be in the final array, then the maximum number of elements which we will have in the final array, if we are choosing this element, it would be minimum of these elements, which is, let's say if this current element is I, it would be n minus I plus n minus I minus 1, and these number of elements, which is going to be the iterator to this element minus the iterator to the first element plus 1 minus a dot begin plus 1. This would be the answer if we are going forward with this element, and we do this for all the elements, and the final mx would be the maximum for all values of I in this. Let's use two pointers in that case. Other n a n and b n where a 0 equals 1, and wait, is the logic correct? Is the logic correct? I think it is correct. Yep, yep, seems to be correct. And I equals 1, I smaller than n, I plus plus b in ai, or remove both of these things. for in reference x in b c in x, okay, and sort a dot begin and a dot end and sort b dot begin and b dot end, okay, and end mx equals initially 0 for int I equals 0, I smaller than n I plus plus, okay, and auto IG equals uh, lower bound or upper bound. We are looking for lower bound a dot begin and a dot end for bi minus 1, bi minus 1, bi minus 1, yes, bi minus 1, and mx equals maximum of mx comma minimum of n minus I minus 1 comma convert into integer it minus a dot begin plus 1, and answer would be n minus mx, and hope hopefully this works. I wait, this should be yes, n minus I, and it minus a begin plus 1, okay, no, this is 1, this says 1, this is, see how mx, I'm messing up with how the lower bound function is working. See out I in it minus a dot begin, yeah, 0 z 0 and then 2. 0 is not very easy, right? We are getting a pointer to the first element in that case. And then why are we getting 2 in the second case? Uh, okay, problem set. We're talking about some problem. Okay, this has officially taken longer than the 1500 rated problem. I'm just being foolish here. Okay, I want to do some experiments. Yeah, test lower.cpp and main, and let's say we have a vector of integers a 1 comma 2 comma 3 comma 3 comma 3 comma 4 comma 5, and okay, auto it equals a dot or standard lower bound a dot begin a dot, a dot, end for 3 and LW auto upper bound a dot, begin and a dot, end for C, and see out the index for these things. LW minus a dot, begin, see out is not included. Okay, include bits slash C++ using name space std and cout copy upper bound a dot begin minus 1, compile and run this 2 and 5. Upper bound is giving us this 3 and lower bound is giving us this 3 and upper bound is giving us 2, 3, 4, 5. This 4. The smallest number that is equal to or greater, lower formal, lower bound C++. Recognition, this must be, yes, sorted in non-decreasing order. It returns an iterator or pointer for arrays pointing to the found element. That returns an iterator to the first element in a sorted range that is not less than first element, that is, okay, lower bound, the smallest element, that is, okay, makes sense. So all the elements to the left of this thing are smaller, right? And if there is no such element, then it returns an iterator to a dot n. And upper bound gives us a pointer to the smallest element that is greater than this element. Okay. I think we can do this. Lower bound in A will give us iterator to the smallest. Okay, yes, yes, yes. A so this is not giving us the right thing when we have 2 here and A is just 1, 1, and we here have also given 1. Yes, we are getting a pointer to the smallest one, in which case this is much better. Okay, shit, I expected this to work. Here this is 4 and we are saying 5. Copy. Wait, okay. Lower bound gives you the first element that is greater than or equal to x. Yes, greater than or equal to x. Yes, that is what. Yes. When we did this with 113, 123 experiment, that is what we got. And upper bound gives you the first element that is greater than x. Okay. And upper bound on b, if we were iterating through a, like not the element, like not the element, but pointer. Yes, but pointer to the element. So we have to use a star to go to that point. If you have already used an element for some element in other array and now again lower bound gives you same pointer, how will you check? Lower bound gives the same pointer. Uh, wait, I'm not okay. I'm not saying that when going through element by element in array B, I'm not checking if I can just use this element. I am checking if I can use this element, then I can have in the final array all of these elements with all of these elements, because all the elements here are greater than all the elements here in A. If I can use this element in B with some element in A. So yeah, whatever is the minimum number among these two numbers, this and this, would be something that can be there in the final array. And yep. Yep. But shit, I think even that would not work, because there might be some elements in this which are way too big than all the elements here, and they could be used with those elements. So okay, again, the initial premise is wrong, so we have to check for each element in B. And yes, I guess I'm overcomplicating this. For each element in B, the best element that can go with that element from A would be the greatest element in A that is smaller than this, which is the definition of lower bound, I think. Uh, the greatest element in A, which is smaller than this, which is smaller than this element in B. So the element in B, which is B I minus 1, take its lower bound with A and remove that element from A and increase the mx by 1. So we, yep, A can be in any order, does not matter. But it does matter, it does matter. It would be good if we were going in this order from smallest in B, and A, for A we want A to be a multiset. Multiset of integers A, there is no size, A dot insert 1, and here in C, take in C, A dot insert C, yep, lower bound A dot begin to end, but auto it equals a dot lower bound for bi minus 1. Yes, that is the number that we want. And if it is not equal to a dot, if it is not equal to a dot end, then we can use this element here. So a dot erase it and mx plus plus. Mm, yes, error because of this. Something is wrong, gravely wrong here. It is this problem is fixed now because I'm removing that element from A and that element specifically from A. And okay, for the first one in A we have 1 and 1, in B we have 2 and 3. Okay, for this 2 we are looking for lower bound of 1 in A, and we get one of these ones. We specifically get this one, and we see that this is not the end, so we increase our max by 1, right? And we remove this number, then we look for this and we land on this number, right? We land on this number and max increases again by 1. So what is the problem? A dot lower bound, a dot lower bound b minus 1. Literally I cannot see the problem here. A dot erase it if it is not equal to the end, right? Mx initially is equal to 0. A is a multiset. We are taking the inputs correctly. Sort B from beginning to the end, and mx equals 0 initially. Then we are going through each element of B and we are checking what is the greatest value and that we can take from A for this current value in B, which is bi, and we are returning mx minus 1. See how I or H. We are going inside this only once here and see out, go to it space 1h1. A end is pointing to 1 past the end. To remove an element from a set in C++. Erase, yes, we are doing that exactly correctly. We are giving the iterator, not the element itself, but yeah, it works. This should at least work for the first keys, but it is not. One test case, n is 2, m is 1, a is 1, b is 2, 3, and we saw 1h, 1, 1. Maybe with vi, c out, b, the sorted array, b, yes. No problem with that. B dot begin, B dot end. Um, why is this iterator not giving us the one which does remain in A dot insert 1, and this is multiset. So C of A dot size, we should see 2, just one test case where n is 2, m is 1, and a is 1, 2, and 3. S is size is 2. For the second iterator, we are getting A dot end, but we should not be getting A dot end. At this point, I want to blame the language itself. Instead of max plus plus, we can do count plus plus when lower bound doesn't find n element. Maybe that should be same. Yes. Let us use two pointers. Bro, why to complicate? We should look for easy way to solve. Yes, we should look for easy ways. But what would be the two pointer solution here? Uh, two pointers. Okay. Yes, it has been 1 hour. Shit, that is very bad. It has been 1 hour. Shit, I removed the problem by mistake. Yep, this one. Trans is easy version. Two pointers. Okay. Vector in A size n, B size n, and we are saying A0 is always equal to 1, and for int I equals 0, I equals 1, I smaller than n, I plus plus C in AI, and for this int reference x in B takes in x, takes in x. Okay, and then we need to sort these things. It's like, yes. So the biggest element for the smallest element in A and B, you are saying we should use two pointers. One in A and one in B, or 1 1 and 2 3. We start our pointer here. Yes, we can use this, so that is okay. Then we move our pointer here, and this pointer also moves towards right. We can use this, so cool. We move both the pointers, but for some values you cannot move the pointer, like here 1 1 5 5, and the second values were these. Okay. 8 is not here, but here, and this 3 can go with this 1, so that is cool. Both the pointers move towards right. These two can go together, that is cool. Both pointers move to the right. This we cannot use, right? So we move just this pointer, and now we can use, so both pointers move to the right. And okay, int I and j equals 0, no, for int I equals j equals 0, I plus plus, I smaller than n, I plus plus, comment j equals I is also equal to 0. Yep. And while, and also is I smaller than j, and I smaller than n, and j also smaller than n. So while bj is, while j is smaller than n and bj is smaller than a, smaller than or equal to ai j plus plus j plus plus, and if j is smaller than n, then max equals 0, then we can choose this pair at the end, mx plus plus, and with this j plus plus, can we increase two numbers? We can increase both of them. See out n minus mx. Hopefully this works. Does not. Okay, I have to go to the washroom. I will be right back in a minute. 1 hour on a simple question. What is your name? Walrus. My name is Ish Haize Jatin Raghav. Yeah. Walrus 137. Yep, I'll be right back in 1 minute after spending 1 hour on a very simple question. I don't know where I am messing up here. And before this, I just did a 1500 rated question. So, yep. Okay, now I'll be right back. 1 minute. And I am totally back. Yeah, I'm skipping this question for now. Save to list. Look into review. Yeah, I'll review this question later on. Not right now. Spending more time is not very cool on this. Okay, and let's do some at least one more question. Yeah, let's do at least one more question. 1500 rating. Mm-hmm. Find the car. Mad, mad sum. Let's do mad sum. Wait, this one looks cool. Expected median. This is like statistics or something. Guess the tree. Dora. Okay. This one. Mad sum. Okay. And some water. Okay. Cool. We define mad, MAD, maximum appearing duplicate in an array as the largest number that appears at least twice, the largest number and that appears at least twice in the array. Specifically, if there is no number that appears at least twice, the mad value is 0. For example, mad of this is 1, mad of this is 3, mad of this is 0. Okay, you're given an array A of size n. Initially variable sum is a variable sum is set to 0. The following process will be executed in a sequential loop until all numbers in A become 0. What is the process? Sum will get the new value of initial value of sum plus the sum of all the numbers in A, and then let B be an array of size n. Set Bi equals mad of all the values till that element. Okay, and then set Bi equals Ai. Okay, can we simulate this whole thing? Find the sum value after the process. Okay, the question is after how many terms will this become 0? N, and yes, then we have A for something like this: 4 4 4 4 4 4. Okay, this is the original A, then we change A. Okay, the first element will always become 0. This we have 4, this we have 4, for this we have 4. Then A would become 0 0. Okay, if we were to simulate this thing, in each operation we would just be removing one element, which would be the worst case. Yes, which would be the worst case when all the elements are equal to each other. But otherwise, in something like 1 2 3 4, the sum would, in initial sum value would become 10, and A would become 0 0 0 0. Yes, and the answer would be 10. I think no, we do not have a test case like that. Answer here is 1. Answer here is 13, because we take the sum of this thing, which is 7 7, and then in the next operation A becomes 0 2 2, and we do 7 plus 2 plus 2, which is 11, and then A becomes 0 0 2, and we do 11 plus 2, 13. Okay. So simulation, do we simulate? If we get to A, if we convert just A once, then we will get something like uh, an ascending array. Then we will get an ascending array. Yes, yes, we will get an ascending array where initial value would be 0 or some initial value would always be 0. The first value would always be 0, and there would be segments of numbers. Let's say a bunch of 2s, a bunch of 3s, and a bunch of 4s, and some numbers. Yep. Then we take the sum of this thing, add that to the sum. Yes. And then how, I think when we have a array like this, we should be able to calculate the final answer. We would be removing, when we update A once more. Yep, we would be removing this. 2 would become 0. We would be taking away one element, one by one, elements one by one. No, shit. At the border also we would change stuff. Yep, at the border also we would change stuff. Yes, yes. If we have 0, 2, 2, 2, 3, 3, 3, 4, 4, 4, let's say, and we were to change, then okay, this is a junction point. This is a junction point. Junction, 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 and at junction point, the next number becomes equal to this number. So this would become 0, 0, 2, 2, and this number becomes equal to this number. So 2, and this number becomes equal, yeah, they would just remain 3, 3, 3, 4, 4, which is like shifting this whole thing to the right, shifting all of these values to the right and removing this number. Okay, okay. So, okay, after updating A once, we will calculate the initial sum to the sum of all the elements in A. Then we will update A once, then we will get something like this, and we will know that this number will be added to our answer once. This number will be added to our answer twice. This number would be added to our answer 3 times. This 4 times, 5 times, 6 times, 7 times, 8 times, 9 times. And we can test this theory for this 4, 4, 4. So sum equals 4 plus 4 plus 4, 16. Then our A is 0, 4, 4, 4. This number is added once, so plus 4. This number is added twice, so plus 8. This number is added thrice, so plus 12. This is 20 plus 20, which is 40. Correct answer. Let's go. In n, take an n vector int a size n. Okay, for int reference x in a, taken x. Okay, and long sum equals 0, not 0. There is a function we can use, accumulate a dot begin and a dot end 0 long. Okay, and yes, we need to update a once. Mad, we have to calculate mad. vector of integers, let's say b of size n, yep, b of size the biggest number that appears multiple times. We will have a set of integers s, yes, and for n I equals 0, I is smaller than n, I plus plus s dot insert a I. I think we should start this from, no, this will work even with 0 here. Before inserting, we'll check if s dot count ai, if ai does exist already, and we will also have the maximum current c mad equals 0 initially. If this current number is already there, then c mad equals maximum of c mad or ai, right? And then insert this number and shit, ai equals c mad. We don't even need this other vector. ai equals c mad. I think this is working fine. Yes. Okay, and then for, we will go from the back to the front. For int I equals n minus 1, I greater than equal to 0, I minus minus, sum plus equals ai into long cnt equals 1 into cnt and cnt plus plus. See out some, this should work. Let's see, and it does not work for the third case. When we have 2 1 1 2, when we have 2 1 1 2, and we have 2 1 1 2, okay, initially our sum would be equal to 6, that is the sum of all these numbers. Then a becomes equal to 0 0 1 2, okay, and then sum would be 6 plus 3 9. That is correct. Shit, when we only have one number here, shit, then this theory actually fails. We won't get one multiple number of times here. Yep, yep, shit. So what do we do? This is definitely going out. So if for all of these segments that we have here, for all of these segments that we have here, if the size is, let's say, x, if the size is x, if the size is x, let's say if the size, if this was 0 0 1 1, if x was 2, then how many times are we going to add this on the next iteration? This would become 0 0 0 1, and then 0 0 0 0, right? 0 0 0 0. But all the things that are appearing only once, they do appear only once. Wait, the message was deleted. Wait, for this or for the last one? For this, we don't have, we cannot sort. For this, we cannot sort. Shit, Bruce saw the deleted thing. Okay. Okay, shit. If a segment has length 1, then it will only be added once. Yep, it will only be added once. It will only be added once. It will only be added once. But if its length is greater than 1, then it will keep shifting towards right. Yep, it will keep shifting towards right. If we have 0, 0, xx, some number x greater than x, x double dash, let's say there are some amount of numbers there, then how many times will this be added and how many times will this be added? Okay. This would be added once, this would be added twice, this would be added from the right. uh, if the index of this number is I, let's say, then this will be added n minus I times, n minus I times. This will be added 0, 1, 2, 3, and in total there are 6 elements. Yes, this would be added 3 times and this would be added 4 times. Okay, we know I and we also know the length of this thing. Length is, let's say, x, and let's say the number here is c. Let's say this is our array 0, 0, cc, and yeah, the index of this number is I, length is x, length is x of this segment, and there are numbers on the right. Then this first number will be added n minus I times. Second number would be added n times, and this will keep on going till n plus x minus 1, n plus x minus 1. X here is 2, minus 2. Nope. N minus I plus x minus 1. Yep, and this would be n minus I plus 1, which would be the end of it. So in total, n minus I plus n minus I plus 1 plus n minus I plus 2 plus dot 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 n minus I plus x minus 1. Yep, plus x minus 1. So yes, plus x minus 1. What is the sum of this whole series? Here we have n a bunch of times, n in total. Here is x times n into x, or n minus I. This whole thing is x number of times for each member of the thing. Yep, and aside from that, we have sum from 0 and sum from 1 till x minus 1. So x into n minus 1 plus x minus 1 into x divided by 2, this whole thing into c. And if x is 1, if x is 1, then we won't use this formula, but if x is greater than 1, at least 2, then we will use this formula. Okay, okay. For int I equals 0 and j equals 0, or let's use, this was a technique I saw in Jiang Li's code at some point when I was actively doing this. While r is smaller than n and l equals r, and we are saying while r is smaller than n and a r equals a l, do l plus do r plus plus. Now, yes, do r plus plus, do r plus plus. The size is r minus l of this whole segment. So if r minus l is greater than 1, which is if x is greater than 1, then sum plus equals a l multiplied by 1 long multiplied by this whole thing, this whole thing, uh, which we can say x equals r minus l and x into n minus I. I in this case would be r minus 1. Yes, I would be r minus 1. So n minus r plus 1 x into this thing multiplied by, okay, shit, this thing is in plus, my bad. Plus here this whole thing, x minus 1 into uh, x minus 1 into x divided by this. Okay, I guess that is cool. Else sum plus equals al only once, and hopefully that works. That does work. That does work. Cool. And let's use this for some. And that does work. So let's check. Previous one. Yo, hello, Eric. How is everything going on? And shit, we used accumulate function. Maybe accumulate is not present for C++ 17. Let's see. Shit, wrong answer on test case 2. We messed up. We messed up. When did C++ added or accumulate C++? STL, when was this thing added? CPP reference accumulate. It should be written here somewhere. Since CPP 20. Okay, and the compiler that we are using here is CPP 17, but we got the correct answer in test case 1 somehow. If we were to change the compiler, maybe. Let's use latest. Okay, and also check the code. This feels right. Yep, this feels right. L equals R, R is smaller than N, and then x is the length of this segment. Yep. Accumulate a dot begin till end set. We have a set, and are we converting a successfully in the first try? Yep. If the current number in AI, in A, which is AI, if we have already seen this number, then update the current mad value to be the maximum of the mad value or AI, then insert this number into AI, and then um, update AI to be the mad, CMAD value. Okay, and yeah, this process is correct. There is no problem with this, and there is also no problem with this. If the size of a segment is at least 2, then we can say that it is propagating towards right. If we have some number of elements to the left, some number of elements to the right, and if we have two numbers C and C. So let's say here on the left there were numbers L, 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 and L. In the next iteration of A, we will have L, L, L here. Yes, but at this point when we are here, we will use L, and here we will use C, and here we will use C. Yes, so this is just propagating towards right. But if we only had one C, then it would not propagate towards right, which we are checking here. If the length is greater than 1, then we are using our amazing formula. Otherwise, we are just adding the value once. Let's look at the test case which went wrong, which is not a very nice thing. Okay, compiler, maybe the compiler was the mistake. I guess not. Shit, yep, no. Don't blame the compiler. The logic is correct. Yes. Yep, the logic is correct. Yes. Yep. Yep, the logic is correct. Let's look at the test case. Uh, we are the submissioners. The logic is correct. Ah, shit, yes, they are here. This failed. Wrong answer. This number is different. Expected 30, found 29. Okay, we cannot manually go and check that thing. There are 15,000 test cases, and we got wrong answer for that third thousand, 3000th one. this should be working. And I initially we are accumulating some, right? We are accumulating the sum initially here, and then we are updating this whole thing, uh, a, then we are updating a once, and then we can basically predict how many times each of the values which are in now in a, they will change. Maybe the formula is not right. Wait, if we shit. Okay, if we have let's say 1 1 1 and 2 and 3 3 0, right? Shit, instead of this 2 here, we will have a 1 here. Next, on the next iteration, we will have 1 1 1. We won't have a 2, we would have a 1 and then a 3. Shit, okay, so this 1 increased by 1. Okay, that is the mistake, that is the mistake, that is the mistake. This one increased, this one increased. Okay, this one increased, and if we had like 3 and 4 here, in that case this one would go, would we would have something like this, 1 1 1 1 1. Yes, this one would occupy the 2's place and the 3's place. Okay, this one would occupy the 2's place and the 3's place. So after finding the size of the segment, we have to see how much right we can go, how much right can we move till we are like seeing this element only once. Yep. Or we can just, yeah, sure, yep. We can just go through this whole array once, see all the elements which are there only once, and yes, see all the elements which are there only once, add them to the sum, add them to the sum, and change one, and change array once more manually. Okay. For which we have to find the size of the segments. L equals 0, R equals 0, while R is smaller than N, and L equals R, and then while R is smaller than N, and A, R equals A, L, R plus plus, exactly what we have written below here. Right, after this we have the size of the segment, and if R minus L equals 1, then we will say sum plus equals a l, sum plus equals a l, and sum plus equals a l, and if l is not equal to 0, l is not equal to 0, then a l equals a l minus 1. Right, we have overwritten this, and yes, we have overwritten this specific element. We have overwritten this specific element, And in our example of this, we would overwrite 2 by 1, and when we are at 3 we would overwrite 3 by 1 also, because now this element, this number is 1 here, this is 1, this would also become 1, and when we are at 4 we would add 4 to our answer and we would make this 1. But one more thing that we have to do is make this number equal to 0, and before that add this whole thing. If 1, then do this, else if not 1, then sum plus equals r minus l into 1 long long into al into a l, and I guess this step should be common. Wait, that is very stupid. We can just remove all this, and now if we have something like 0 0 1 1 1 2 3 4, we will see this thing, we will add 0 to our sum, we will see this thing, we will add 3 to our sum, we will see this thing, we will add 2 to our sum, and when we were here we would override this by 0. Yes, we would override this by 0, and we would, when we were here we would override this by 1. Yes, and okay, if this was 3, then we would also override this by 1. Yes, makes sense, makes sense. We would override this by 1, and yeah, we didn't, if we did have a 3, does not matter. 4 3, okay, yeah, cool. This works, this works. Or maybe not. For the second case, we are getting 11 instead of 13, which we should be getting. And the second case is this: 2 2 3 2 2 3 2 2 3. Initial sum is 7, which is the sum of all of these values, and a becomes 0 2 and 2. Correct. Yes. And okay, then we update this thing once more and we make it 0 0 2, and we add 4 to our answer, and this becomes 11. And then we see this, which we should be adding to our answer, which else sum plus equals al. Okay, we already removed all of the places where this thing was only appearing, all the segments of size 1. So the only place where a segment of size 1 would appear would be at the end. Yes, which we are adding only once. Cool. Submit. Yes, submit. Running, and hopefully this works. Okay, wrong answer on test case 6. Wrong answer on test case 6. This is warning. Find integer overflow at this point. Do you have to take median, or for each test case output the sum in a new line? Okay. This is integer overflow somehow. Why? Because x is very big. Maybe x is very big. Okay. In which case we should say long long, and these should also be converted to long long, or everything should be converted to long long. Substitute int with long long, except n is not long long. Substitute int with long long. Now we should not be getting that integer overflow. Okay, 40 minutes for this question, if it is correct, which it should be, hopefully. Okay, it is correct. 40 minutes. No, 40 minutes is still like a bit too long. 20 or 25 minutes would have been cool. No, but slowly I will catch up his speed. And I guess that would be it for today's stream. We did two questions, two 1500 rated questions, which is not a lot of work, but we spent more than 1 hour on that normal 1400 rated question. This one. Wait, shit, this one is also 1500 rated. Wait, it was. That question is not here somehow. The 1400 rated question. I didn't submit it. Not even once. Okay, that is sad. But yeah, we spent more than 1 hour on that question, and yeah, that's like 3 hours, therefore. And for today, that would be the end of the stream. We did two questions, 1500 rated, and yep, slowly we'll improve and do more questions and higher rated questions. And yep, thank you for being here. Bye.